Good morning, everyone.
Good morning, sir.
So today we'll discuss the last chapter, that is magnetic field and field lines, right? So is there any concept in this which you are not clear with, which you want me to explain? Or can we directly start doing problems?
Sir, can you teach about solenoid, sir?
Okay. The solenoid?
Sir, and about AC and DC current.
Mm-hmm. 1 minute, let me check.
Sir, AC and DC is limited, right?
That's deleted actually.
Only the motor is related, no, sir. The current concept, I guess, it's there.
1 minute, I'm checking. Alternating current is there. Yeah, it is there. Motor is deleted. 1 minute, it's 2022-23, right? Yeah. So in 22-23, you have this concept, AC and DC you have. Okay. So basically, you want solenoid and advantages and the differences between AC and DC. Am I right? So these are the two topics you have told me.
Yes, sir.
Right. Okay. So first, we'll start with solenoid. So basically, what is this chapter all about? Magnetic effects of current. It is all about what? It is all about how a current carrying conductor
produces magnetic field.
That is the whole idea, right? Produces magnetic
field.
Right. Now, 1 minute, just give me a minute. Hold on. So what is a solenoid basically? See, if you take a long rod and wind a coil around it, right? So basically, are you accepting that when I say magnetic effects of current here, the magnets that we are dealing with are temporary magnets? So why do we call them as temporary magnets? Because as soon as you remove the current flow through the conductors, what will happen? The magnetism is lost. Yes. So these are also called as electromagnets because you are using electricity to generate magnetism. So solenoid is also an electromagnet in such a way that you have a coil that is wound around something, right? Now, in this, suppose I'm passing current here, then the current will go in a circular path and come out on the other end, right? So what you can do is you can see from here or you can see from here. So depending on where you are seeing from, the concept of solenoid will be meaning. I'll show you how it works. See, suppose this pen is the base on which I have coil windings. Okay. So on which I have the coil windings taking place. Now, if I want to see from this side, that depends on how the current is going to flow. So if I see it like this, if the current is going in this direction, then at the top, the current will be entering into the plane. And at the bottom, the current will be coming out of the plane. Are you able to visualize that?
Yes, sir.
Right. Now the question is, if the current is going in this direction, so when I see from this direction, what is the direction of current that is going?
Anti-clockwise.
Anti-clockwise.
Anti-clockwise. So when you have this anti-clockwise current, right, then what pole is going to get generated here?
North pole.
North pole.
So similarly, if you have clockwise, it is going to be south pole.
The south pole.
What is happening is solenoid is able to generate north pole on one side and south pole on the other side, as a result of which it acts like a magnet for sure. But solenoid is said to be equivalent to a bar magnet. You know what is a bar magnet, right?
Yes, sir.
So solenoid is said to be equivalent to a bar magnet. So that is how it works. Okay. So one. Now, the next question is field lines. So according to magnetism, we know that the field lines due to a magnet are away from the North Pole and towards the South Pole outside the magnet, right? Whereas inside they are going to be from south to north. Accepted? So what is happening? Outside the North Pole, they are from, sorry, outside the magnet, they are from north to south. Inside it is going to be from south to north. So this is how a solenoid is going to function. Nitin, did you understand?
Yes, sir.
So,
okay. See, mathematical parameters are actually not there. Okay. So I'm not getting into those details. One side will be north and the other side will be south. Do you know the fact that why anti-clockwise currents generate North Pole? Or how to remember if anti-clockwise currents generate North Pole? You know that? So if I take the current to be in the anti-clockwise direction, you can remember it like this. This is called as clock rule.
Clock face rule.
So you can remember it like this. N here stands for north and here stands for the south. Okay. And the idea comes from very simple logic. What is it? It comes from the basic. How do you find the direction of magnetic field due to a current carrying conductor? What rule do you use?
right hand
That-
thumb rule.
Right hand.
It's right hand thumb rule. So what does right hand thumb rule state?
The direction of the thumb finger represents the direction of current, and the direction of other fingers represents the direction of the magnetic field.
Yes. So basically you need to take the right hand and place the thumb in the direction of current and curl the wire as if you are holding it. So the direction in which the fingers of your right hand is getting curled is going to give you the direction of magnetic field. Okay. The next question is about AC and DC. Right. So what is AC basically? You know the full form of AC, that is alternating current. What is the full form of DC? It is
Direct current.
Direct current.
direct current. So what is the difference between both? Alternating means
The
What
current
do you-
frequency will change.
current will change.
Yes,
The
sir.
direction of the
The
current
direction of
will
current
change
will
The
change.
direction of current will change.
Okay. Now tell me one thing. If I draw a line like this where it shows the variation of current versus time, what kind of a current is this?
Direct current.
Direct current.
It is direct current. Okay. If I draw something like this, what is this?
Alternating.
Alternating current.
If I draw something like this,
Alternating current.
it is again AC. No?
Alternating.
This one?
Alternating current.
This is also alternating current, right? But that is wrong. It is actually direct current.
How, sir?
I'll tell you, wait. You will get the answer. So this is where you need to understand one thing. So when you talk about direct current, right, or alternating current, you need to look how the waveform or the graph is aligned with respect to y-axis. So if it is above y-axis, you take every point inside it to be positive. Everything below y-axis will be considered to be negative. Am I clear with this? If you observe this, here everything is positive only. So for an alternating current, what did you say? Direction will change, right? So direction has nothing to do with the graph shape. Direction has something to do with the positive and the negative. That is why alternating currents are called as bidirectional currents. If you have not heard this term, write it. They are called as bidirectional currents, whereas direct current is called as unidirectional current. Means even if the graph is having bends, but if it is confined only to one direction, then still it is called as a direct current. This is actually called as unregulated direct current. It is unregulated. It is not having a fixed value, because we are always under the notion direct current means it should have a constant value of amplitude. No. Constant current. No, constant current doesn't mean direct current. Direct current means direct
Bidirectional
current
current.
means unidirectional. Bidirectional is alternating.
Oh, sorry.
Okay.
So what if in the fourth case the race was the waves were in down position?
It is still unidirectional. If it is only in one direction, it is unidirectional. See, for example, if I have something like this,
Ah,
only negative, no, it is still a direct current. Because it is one direction, only negative sign is there, no positive sign. So basically, this positive sign is called as positive cycle, and this is called as negative cycle. Are you able to understand? See, about this in depth you learn in your 12th standard. Don't worry about it. Just give me 2 minutes. Next, see the question is, what are the advantages of AC over DC? So what are the advantages? Can someone tell me?
So the AC current can be transported easily.
First thing, even before we transport, it is important that we generate. Right? So generating AC is much cheaper than DC. Because when you want to generate AC, according to Faraday's law of electromagnetic induction, you need only magnet and a coil. Whereas for DC, what you need is you need the electrolytes and everything to get generated, which is again going to be very, very, very costly, right? So generating AC is much cheaper than DC. Second is, when you try to supply AC over, we generally get a 230 volt and everything. This is a very high value, right? At our house, we get 230 volt. No, is that AC or DC? We get 230 volts at our house. 230 volt and 50 hertz. Hertz is generally used only for something which is changing. So it is an alternating voltage.
So
Right.
230 or 220, sir?
220 or 230, it can be somewhere between. That is how we say. In India, it is somewhere between 220 to 230. In US and all, it is somewhere around 110. That is why their adapters and all will also be slightly different. See, some books write it as 220, some write it as 230. If you go to real-time devices and see, right, for example, your fan, tube light and all these things, there it will be written as 230 only.
Okay, sir.
Yeah. So AC at higher voltages can be transmitted with lesser loss. Compared to DC. So we need to transfer this much. See, 230 volt is not the exact voltage that is actually getting transmitted. Do you know that we actually get more than this, but that value is actually reduced? Guys, are you able to understand what I'm saying? The power stations and all will actually not send 230 volt. It will be sending more. So that value will actually get stepped down to this value of 230 volt. It will be brought down. So which is a big advantage with AC, means you can actually change the value of voltage that you want. Using a device called as, any idea about what device changes the voltage?
Transformer.
Yes. So you have transformers, right? That is it. And one more advantage is AC can be easily converted to DC.
To DC.
Using what? Using devices called as rectifiers, about which again you will learn in your 12th standard. I'll give you the best example for it. See, for example, you have your mobile phone, you want to charge it, right? You connect it to the charger which has an adapter and you put it into the plug. So here, how much is the value given by the plug? 230 volt. If this 230 volt directly comes to your mobile, the first thing that you will see is your mobile will blast. Okay. So it cannot hold that much value. 230 volt is not needed. So what will happen is this 230 will be first converted to, will be stepped down. Step down in the sense, let's say you want 12, 9, 10 volt, whatever you want, it will be first step down to that value. And when it is stepped down, you will get, for example, 10 volt, you will get it as AC only. Okay. Then this can be converted to DC using a device called as rectifier, about which I cannot explain it in detail now. Okay. But I just gave you this so that you will understand the real-time application. Are these 3 points clear to you?
Yes, sir.
Yes, sir.
Please make a note of it. So I suggest everyone to write it down. have your notes and also write down the points which I told you. Okay, shall I proceed, guys? Can we do some problems now?
Yes, sir.
What is the answer for the first one? What capacity of fuse wire is used for geyser?
15 amps, sir.
It is 15 amp. See, generally when you go to a shop, right, and you ask for a plug or something, okay, they'll ask you two questions. Do you want a 5 ampere or a 15 ampere? So 15 ampere is the one which is used for heavy load devices like geyser, refrigerator, electric heater, all these things are there. No? They are slightly heavy load devices. For them, you need to use 15 amp. Whereas for smaller ones, okay, you can use, for example, your TV, computer and all those things, you can use the 5 amp. Next. An electron beam is moving vertically upwards. If it passes through a magnetic field which is directed from south to north in a horizontal plane, then which direction will the beam be deflected? So there is a magnetic field existing from south to north. An electron beam is moving vertically upwards. If it passes through magnetic field, 1 minute, okay.
Is it towards east?
How did you find it out?
There was an experiment in the textbook, sir. If it, yeah.
Advana, you give me the logic, okay? Forget that experiment. So listen, you know this fact that a dot with a circle around it says that it is out of plane. Do you guys know this?
Yes, sir.
Yes, sir.
Into with a circle mark around it shows into the plane. Right? So here if you read, an electron beam is moving vertically upwards through a magnetic field which is directed from south to north in a horizontal plane. Then in which direction will the beam be deflected? Yeah, I have to show this, okay? Only then you will give this. If this is the book, okay? I am south pole, you are north pole. So south to north is this thing, and electrons are moving vertically upwards. They're in a different plane. Are you able to visualize this?
Yes, sir.
Yes, sir.
Now listen to this carefully. In which direction? So when a charged particle is entering a magnetic field, what will happen to it? It will start experiencing.
It will deflect
Why will it deflect? Because it starts experiencing
the magnetic.
force. It experiences magnetic force. Am I right? Now, for force, right? So there are two things. You can either place a current carrying conductor in external magnetic field, or you can make a charged particle move in a magnetic field. In both these scenarios, there will be force experience. So to find the direction of force, what rule are you going to use?
Right hand thumb.
Fleming's left hand.
The Fleming's
Fleming's
left
Right hand,
rule.
right hand thumb rule is for magnetic.
Sorry, sir. Sorry.
Fleming's
Left hand rule.
Left hand rule.
left hand rule. Okay, in the Fleming's left hand rule, what does it state? Extend your forefinger in the direction of field, central finger in the direction of current, and the thumb represents the direction
Thumb
of
fingers motion.
So forefinger, F-ler. So forefinger is field. Central finger C, another current. Thumb T, another thrust. So, right. Now coming back to the question, visualize it, okay? See, this is the only question I'm going to give you detailed explanation. Next one you are going to solve. So, horizontal plane of your paper. So, your paper on which you are writing is acting like the north south. So, you're the you're the south pole. Opposite to you is the north pole. You have a paper like this, right? You are the south pole. Opposite is north, right is east, and the left is west. Correct. So if you read the question carefully, they told that the electrons are moving vertically upwards, means they are coming from bottom to the top. When they are moving in that way, what is the direction of current according to convention? The direction
Opposite.
of current.
Opposite direction.
So if the electrons are moving upwards, current will be in the downward direction. Correct?
Yes, sir.
Now apply the Fleming's left hand rule. First, so don't extend everything and keep tilting your hand like this. Okay, go one by one. So there will be two quantities which are known, third will be unknown. So first go in the order of known. First, you know the direction of field. Field is in the direction of south to north. Okay. So what is the direction of current in this scenario? Top to bottom or bottom to top?
Top to bottom.
So I extended. This is the direction of current. And when I extend the thumb, this gives me the direction of force. So what is the answer for that?
Towards east.
Towards
Towards
east.
east.
You're right. Okay. So had the same question, if I want to twist and ask you, had I told, instead of electrons, had I told they were positive charges, then what would have been the direction of force? They would have got reflected to the
West.
West.
Okay, you need to be careful with that. So towards east. What are the constituents of alkali?
B, sir.
Aluminum, nickel, cobalt. Who said that current can cause magnetic field?
Orsted.
First.
Correct. So what is the current rating of domestic circuits used for appliances like electric bulb, tube light, and fans?
5
Five
amp.
5 ampere.
5 amps.
I told you 5 or 15. Okay, 15 is for heavy load, 5 is for less load. When a coil current carries a current in anti-clockwise direction, what pole does it create? This also I
South
showed you.
North pole.
North pole.
Okay.
South pole.
Anti-clockwise.
Oh, south.
Anti-clockwise.
North pole.
North pole, sir.
North
North,
pole,
sir.
sir.
Yeah. What is magnetic effect of electric current?
The field exerted by the magnet is known as magnet.
See, simple. As the name suggests, when electric current is passed through conductors, magnetic field is generated around it. That's called as the magnetic effect of electric current. So, what precautions should be taken to avoid overloading of domestic electric circuit?
We should have fuse.
Okay. Is that the only precaution you will take?
Do not
See,
connect.
domestic electric circuit, something domestic is our house, right? Domestic is opposite of commercial. So in our house, are we going to use only one device? No, right? So when you're going to use the devices according to our requirement, you will have heavy load devices and less load devices. First thing is ensure the devices are connected according to their power rating. Am I right? See, for example, don't take a fridge and connect it to 5 amp and don't take fan and connect it to 15 amp. They should be connected according to their power rating. Right? Secondly, don't connect too many electric circuits
In a single socket.
to one socket. Right. And thirdly, use a fuse of appropriate current rating. So these are the 3 points you need to be careful with. Right.
Can you show that?
Yeah.
Okay.
Hmm.
Then scroll.
Sorry.
You can scroll down, sir.
In activity shown, how do you think the displacement of rod AB will be affected if the current in AB is increased? And second is if you use a stronger horseshoe magnet. Can you tell me? So I'll just give you a mathematical relation. This is not a part of your syllabus. Force experienced by a current carrying conductor is equal to B into I into L. Okay, actually it is BIL sine theta, where theta is angle between B and I. Actually, it is B and L. I is not a vector. Okay, but as of now, you can write down this one. What is it? It is BIL sine theta. So from this, what are you able to understand? Force is directly proportional to current. Now will you be able to answer the first one? If the current in the rod AB is increased, how do you think the displacement of AB will be affected?
It will
If-
increase.
If I is increased, F will increase. If F is increased, displacement will increase. Now, if I use a stronger horseshoe magnet, then what am I increasing?
Same.
So I'm increasing the value of B. When B is increased, F will increase. When F is increased, again displacement will increase. So you need not write this thing in the exam, okay? So what you can write is, since force is directly proportional to the current, okay? Since force is directly proportional to the electric current flowing through the circuit, so when current is increased, force will increase, hence the displacement will increase. Similarly,
So do you have to write it in statement that force is directly proportional to
yeah, you can
current?
write it. You have to write it. You have to write it. You have to write it.
Okay, sir.
Hmm. 58. A plotting compass is placed inside a solenoid and a compass needle is pointing in the direction as shown. Okay. Complete the circuit diagram by drawing the arrowheads to indicate the direction of current flow. It's a good question. They should have actually not given battery, but okay. Battery is given, you will be able to find the direction. Keeping that aside, see, if you see from this side, what pole is this?
South Pole.
What did I tell you? Inside the magnet, inside the solenoid, the magnetic field is from
South to north.
south to north, no? So then this should be the North Pole, no?
Yes, sir.
Got it? Then this will be the South Pole.
So can you explain again? I didn't get it.
Now, inside the magnetic field, what is the direction of, sorry, inside the solenoid,
Magnet.
what is the magnetic field? It is from south to north, no? I told you, Lama, see, when you take Always imagine with a bar magnet. For a bar magnet, the magnetic field outside is from north to south, whereas inside it is from south to north.
Yes, sir.
Got it? So this is the North Pole. Right side is the North Pole, left side is the South Pole. When that is the case, when you see it from this side, how should the current be? The current should be in the anti-clockwise direction. So the current, so one side if it is anti-clockwise, the other side it should be clockwise. Okay, so current should go in this direction. It goes like this and it comes down like this. So second question I've already answered. Describe the direction of magnetic field inside the solenoid. It is always from the induced south pole to the induced north. Okay. Mark it as. States Fleming left-hand rule. I've already told this. So state Fleming's left-hand rule. Tell me fast. Extend the forefinger, central finger, and thumb mutually perpendicular to each other, so that the forefinger points in the direction of magnetic field, the central finger in the direction of current, and thumb gives you the direction of thrust. Force. Yeah. Second, list 3 characteristic features of the electric current used in our house. So first,
It's AC current.
it is AC. Second, current supplied is, see, actually, I think according to your NCERT, it will be 220, right?
Yeah, sir.
But I suggest you guys go to electrical shop, or if you have any devices at home, bulb you'll have that box, no? See on that what is the rating given. Actually, it is 230. It's okay. It's okay. We'll go for that sake, for the exam purpose. Okay. Next. And the third point is neutral wire and live wire carry current. Okay. Third, what is a fuse? So what is fuse? Fuse is basically a safety device. And what is its job? So safety device means there might be 2 kinds of accidents. What are the 2 kinds of accidents possible? One might be due to the One minute. See, safety device, 2 kinds of accidents are possible. One is due to overloading, and the second is due to short circuit. Right? And the second is possible due to short circuit, right? So what will it do? Why? How will this device protect us from this accident? So what principle does it use take into consideration? It uses
It
the
has
concept
low
of,
melting point.
No melting point.
yes, it uses the concept of Joule's law of heating. And due to low melting point, what will happen? For the small amount of heat that is getting generated, it will get melt, right? The fuse wire will actually melt, and due to melting, what will happen? It breaks the circuit. So if it has to break the circuit, then how should the fuse wire be connected across the circuit? If one device stops
In
working,
series.
it should be in series. Because in series alone, if you lose one device, the other devices in series will also stop working. And last, so why is it necessary to earth metallic electric appliances? So basically metals are
Good
what
conductor.
good conductors. So are we, right? So here also good conductors of electricity, right? So when live wire, see for example, when live wire touches the metallic electric appliances, what will happen? Suppose live wire touches the electric appliances, then what can happen is it will make the current to flow through, right? It will make the current to flow through earth instead of our body. As a result of which, what will happen? We will escape from getting that shock, right? So why is it used? What are the two keywords that you're going to write? One is to prevent shock, and the second is saving electrical appliances from burning. So saving electrical appliances from burning, okay, and to avoid the electric shock. So these are the two keywords that they will expect. See, everything is there in NCERT. Purely go with your NCERT for this part. Okay. So actually, these are all the few important questions that I've taken. Okay. So actually, we were supposed to have this along with this chapter, no? Electricity. Okay. So I hope you could understand, right? Is there any other question that you have in your mind which you're not clear? Any concept or any question that is not clear? Guys, are you there?
Yes, sir.
Okay. So any other question? That's it?
Yes, sir.
Yes,
Okay.
sir.
Then we'll wind up.
Thank you.
Okay. Prepare for tomorrow's test and do it well. So you would have got this assignment, by the way, right? So look for some more questions from that also. If you have any doubt, reach out to me.
Okay, sir.
Okay, sir. Thank you, sir.
Yeah.
Thank you, sir.
Yeah.